Okay, let's solve some more square root equations. So that's, equations that have a square root in them. Um, the, all ones that have radicals are kind of solved in the same way. In this case, we're going to square things because it's a square root, but you could, cube things if that were a cube root. Remember that these ones have domain restrictions on them, so we can't have anything that would make this expression come out negative. So sometimes I go ahead and check that first. But I'm actually just going to go ahead and go through this one because I'm going to check it at the end anyway. Check my solutions at the end anyway. So I'll catch those bad ones if it is a problem. So I'm just going to go ahead and go for it. Now, the reason why I put this one as multi-step because it requires maybe just a little bit more algebra than some of the ones that you saw in the other videos. But it's the same idea. I'm just trying to get at this m. The m is inside a radical, so I get to get rid of that radical, and I'm going to get rid of this radical by squaring because it's a square root. Now, what makes this a little more work is now we're going to have to square this binomial. So hopefully everybody knows that this is actually this. It is not m squared minus 16 or m squared plus 16. It is neither of those things. You can't just square each of these. You have to FOIL this out, or whatever word you use to describe distributing these things. Okay, so when we do this side, don't forget that you have to multiply it all out. So over here, this side is easy because it's just a radical. But over here, we're going to get m squared. When I multiply these two middle terms with what I call my smiles, right? I call those the smiles. I get 8m, and then I get a positive 16 for the last term. And now I have to solve a quadratic equation, which I know some of you don't enjoy, but that's the way the cookie crumbles. There's worse things that could happen to you today than getting a quadratic equation that you have to solve. Now, I'm hoping that it's going to be factorable, but if it isn't, it doesn't matter because I know how to solve them. You can use completing the square quadratic formula and factoring. You could even, graph them, or there's other things you could do, but you know how to do all of those things, so it's no big deal. So what am I going to do? I'm going to try to factor it first. So I'm going to get it set equal to 0, so I'm going to move everything to this side just because the m squared is always already positive, and I like it to be positive. So what's that? A negative 15m when I subtract 7m from both sides. And now I'm going to add 38 to both sides. So what is that? A 4? Is that a 54? I think it's a 54, right? I think that sounds good. All right, so now we need factors of 54 that add up to 15. So what do you think? Any guesses? So I'm going to make my little parentheses here, and I'm going to start to think about factors of 54. So, I could write them out over here. 54 and 1 definitely is out. I'm going to go with the one I know best, which is 6 and 9. But of course, there would be a 3 and a 27. Would it be? No, 3 and whatever. But I'm going to try the 6 and the 9 because that's the one I know. We could write them out over here. So 6 and 9, or you could do 3. Oh, it's 3 and 18. Sorry. Or there's a bunch of different ones you could try. But 2 even, right? 2 and what is that? 27. So there's a bunch of different ones you could try. I would have thought of this one first because 54 makes me think of that one. So that's the one I'm going to try. So I'm going to put a 6 and a 9. I know these first ones have to be m's to get my m squared. And so now I'm going to try these smiles, right? The smiles that I talked about earlier. And I need it to come out to be a negative 15. So if I have a 9m and a 6m, that's what would happen if I were to multiply these together. And I need it to be a negative 15. Well, obviously I need both of them to be negative, right? Now, it is possible that you could have picked this one. The trouble with that one is, let me show you, because I know a lot of you are like, oh, why isn't it that one? So 3. So this is an aside, just so you can see. This will be a 3m and an 18m. Now, here's the kicker. This has to be positive, right? Which means both of these have to be the same sign. Because in order to get a positive product, they either have to be both positive or both negative. So if I make these both positive, that's not going to be a 15. And if I make them both negative, it's not going to be a 15. So I would have to make them opposite signs. And this one doesn't allow for opposite signs. Okay, so I know that it's the 9 and the 6 and not this one. There are not two answers to this. This does not work. Everyone see what I'm talking about? Okay, so I'm going to make these both negative. So I get m minus 9 is equal to 0 and m minus 6 is equal to 0. So I get m is equal to 9 and m is equal to 6. So I just use my zero product property. And now here is where I'm going to check it. I'm going to check it in the original because remember, these can have extraneous solutions. So I'm going to do my check. Now from here, if you want, I'm going to just show you a little trick. If you want to actually check it on your calculator, you can. So I only have 2 to check, but if you had a whole bunch, or if you're just trying to save time, maybe you're not quick with the multiplying and the algebra, which some of us, are not. What you can do is you can go to y equals and clear out whatever's in there. I'm going to put this in one side. So I'm going to do square root of 7x minus 38. And then I'm going to do another equation, which is this one. So I'm going to do just m minus 4 was our original, right? It wasn't. It was m minus 4. So I'm going to use x minus 4 because that's what the calculator uses, okay? Then I'm going to go to the table. Now the values of the first one are going to be here and the values of the second one are going to be here. And everybody knows that if your numbers are solutions, then they have to be the same. So let's try our 2 numbers. So I'm going to try a 9. And they both came out to be a 5, which means 9 is a solution. Let's try 6. And they both come out to be a 2, which means they are a solution. And if you were to look at their graphs, I don't know, let's see if we can get the graph here. You can see that this line is going to intersect that square root function, right? And it intersects it twice. It intersects it at 9 and 6. So it intersects it at 9 and 6. It's hard to see in this picture because it's kind of zoomed out and I don't want to spend a ton of time doing that. And of course, what you could do here too is just plug it in. You could just plug these in and make sure that they come out to be the same on both sides. Okay, so that's the 2 ways that you can check, or the 3 ways. I showed you with the graph, I showed you with the table, and with the algebra. Okay, so make sure that you're going back and checking those because sometimes you get 2 answers and one of them's no good, and sometimes actually both of them are no good. But in this case, both of these make it true, so they're both good solutions.